Verify that the following functions are inverses of one another. The cube root of 2x minus 5, and then the inverse is x cubed plus 5 divided by 2. So if these two functions are inverses of one another, then if we complete a composition, in other words, if we're going to substitute one function into the other function, this should equal x. In other words, all of the operations should be completely undone, and we should be left with just plain x in the end. So let's actually do this algebra. So this is saying, the way I have this written, that the inverse is on the inside. We're going to be taking this inverse function, and we're going to input it in place of x into our original function f of x. So we're going to have the cube root of 2, and then instead of x, we're saying 2 times, here goes my inverse function, x cubed plus 5 divided by 2, and then we have minus 5. So that's my initial composition, and now we just need to simplify this. So we notice that the 2's divide out. That'll leave us with the cube root of x to the 5th plus 5 minus 5. Then our 5 subtract out, leaving us with the cube root of x cubed, which indeed simplifies to equal just x. So this does check out. This particular composition works. We see that every operation has been undone and we're left with just x. But if it works this direction, it should also work in the other direction. In other words, if we did the composite this way instead, where now my inner function here, the inside function, is f of x. So now we're taking function f of x and we're substituting it into the inverse in place of f of x. This should work as well. So let's show this just to be sure. So instead of having x cubed in our function here, we're inputting the we're inputting the original function, the cube root of 2x minus 5. And then we have plus 5, all divided by 2. So we just put the original function into the inverse. And now we just simplify. So once again, the cube root is going to be undone by the cubing. So we'll be left with just 2x minus 5 plus 5, all divided by 2. And then you see that the 5 subtract out, and now we have 2x divided by 2, which indeed simplifies to just x. So this checks out as well. So because both of these compositions equal just x, we can safely say that the original two functions are inverses of one another. Here are our next two functions that we want to verify that they are inverses of each other. So once again, we will start with a composition. So I'll start by putting the inverse here, the inverse, as my inner function on the inside. So I'm going to take the inverse and I am going to input it into my function. In other words, I'm going to substitute it in place of all of the x's. So be careful here because you'll notice there's actually 2 x's in the original function, so we'll have to substitute the inverse in both of those places. So we'll have 3 times, and then here goes my inverse in here, 3 times negative 2x over 3 minus x, all divided by my inverse, negative 2x over 3 minus x, minus 2. So there's my initial substitution, substituting the inverse into the original function. Now we need to do quite a bit of algebraic cleanup here. So remembering that there's just a 1 under this 3, so we're multiplying our fractions in the numerator. So 3 times negative 2x will just be negative 6x, all divided by 3 minus x. That's my numerator. And then down here in the denominator, this is a 2 over 1. So we need to get a common denominator, which would just be 3 minus x. So I'm going to multiply the numerator and the denominator here by 3 minus x. So I can get a common denominator. So I'm going to have a common denominator of 3 minus x. So my numerator will just be negative 2x minus 2 times the quantity 3 minus x, which I will choose to clean up here on my next step. So the numerator hasn't changed. I'm leaving that as it was before. And now I can go ahead and distribute here in the the denominator, and simplify. So we'd have negative 2x minus 6 plus 2x once I distribute. And then you'll notice what happens here. The 2x's subtract out. So right now I have negative 6x divided by 3 minus x, and then this whole quantity is divided by negative 6 over 3 minus x. So this is a complex fraction, and at this point it's probably best for us to change our division. Here's my big division bar here. Change our division. Instead of division, let's multiply by the reciprocal. So the numerator here, the negative 6x divided by 3 minus x, does not change. But then we change our division to multiplying, and we multiply by the reciprocal, which means I would have a 3 minus x in the numerator here, all divided by negative 6. And before we multiply, we can certainly simplify. The 3 minus x's will divide out, as will the negative 6's. So you see that we indeed end up with just x. So it does check out. With this composition, we get exactly what we were hoping to get to verify that these two functions are inverses of one another. Now we want to verify the other composition. So now we'd want to verify that the inverse composed with the original function will also equal x. So this time, the inner function, the inside function, is f of x, so I'll be taking f of x and I will be substituting it into my inverse function everywhere we have an x. So this will look like negative 2 times, and here's our function going in, f of x is 3x divided by x minus 2, all divided by negative, oops, excuse me, that wasn't a negative. There we go, try again. Our function, which was 3x divided by x minus 2. Oh goodness, my apologies. Try again. Rather than redoing this. Sorry, I'm looking right here at my denominator, which should be 3 minus, there we go. Now my function is 3x divided by x minus 2. So here's my initial substitution, the original function getting substituted into my inverse, and now we just have to do our cleanup. So this is a negative 2 over 1, multiplying my fractions here. I'll have negative 6x divided by x minus 2. Denominator, I have 3 over 1. I've got to get a common denominator again. So I'm going to multiply top and bottom. I'll multiply by x minus 2 to get a common denominator. So my denominator will just be x minus 2. And then if I can go ahead and distribute here and save a step, might as well. I'll have 3x minus 6 and then minus 3x. So we'll notice that the 3x's are going to subtract out. So at this point I have negative 6x divided by x minus 2, all divided by negative 6 divided by x minus 2. So once again, I will treat my division here. If I think of this as just division of two fractions and realize that we don't care to divide two fractions, but rather we will change it to multiplying by the reciprocal. Then my numerator, the negative 6x over x minus 2, stays as is. My division becomes multiplication, and then I take the reciprocal of my denominator, which puts the negative 6 on the bottom and the x minus 2 in the numerator. And then simplifying, we see that the x minus 2's divide out, as do the negative 6's, and yep, it does simplify to be just x. So we have verified with both compositions that the original two functions are indeed inverses of one another.